2010, the world population was about 6,860,000,000. Population of the United States was about 3 times 10 to the 8. About how many times larger is the world population than the population of the United States?
Okay, so let's go through and underline our important facts. What's something that you think we're going to need to know? Autumn? Okay, so in 2010, the population was about 6,860,000,000. Okay, what else do we need to know? Tristan?
3 times 10 to the 8.
Okay, in the United States, it was about 3 times 10 to the 8th. What else? Michaela? What's the word before that? About. What does about mean? Estimate. Okay, what do you do when you estimate? You round. Okay, so about how many times larger is the world population than the population in the United States? Okay, so first of all, let's deal with this number of 6,860,000,000. What if we rounded this to the greatest place value? What would it be? We rounded it to the greatest place value. Landon, what do you think?
Alright. I think it could possibly be the good old 9.
Where'd you get a 9 from?
Alright, so you see how many zeros it has?
Okay, did you listen to my question?
Yeah, you round it.
What am I rounding, though? What number am I rounding?
6.8.
The 6,
And
right?
8, yeah.
So does the 8 tell the 6 to go up or stay the same?
Oh, go up.
Okay, so it should be what?
7.
7, and then we need
7.
9 zeros. Okay, so 7 billion. Okay, so that's what we would round it to. Let's put that into scientific notation. Put that into scientific notation for me. Caitlin? To the what, sorry? To the 9th. Okay? Because remember, you have to move your decimal place until you have a number that is between 1 and 9. So therefore, you have to move it 9 times. So 7 times 10 to the 9th. Okay, we need to know about how many times larger it is than the world population than the United States population. Does this number represent the world or the United States?
World.
Adriana?
World.
It's the world, right? Because it says the world population. Okay, so this is world. Oops. Okay. And we're going to divide it by the U.S. population. So what number goes with the U.S. population? Tristan?
3 times 10 to the 8.
Good. Okay, when I am dividing, what do I do with my numbers? Like the decimals. What do you do with the decimals? You what, Bailey? Divide. So let's take 7 divided by 3. What do you get? Take 7 divided by 3. What do you get?
2.
Okay, so 2.3 repeating. If we rounded it to the nearest 10th, what would it be, Sean? If we rounded 2.3 to the nearest 10th, what would it be? Okay, so 2.3. We can do that because we're estimating, right? We still have to do our exponents, though. When we are dividing with the same base, what's the rule for our exponent? Michaela? Subtract. So 9 minus 8 is?
1.
So we have times 10 to the first. Okay? That would be in scientific notation. If I wanted to actually solve it out, which is what the book did, I would take 2.3 times 10, and you get what?
23.
2.3 times 10 is 23. So that's how the book got the final answer as about 23 times larger. Okay? Questions on that one? Okay, I'm going to do got it C with you, and then you're going to have to do one on your own. So got it C is on the other page. Would somebody, Dalton, will you read that one?
Okay. The surface area of Lake Superior, the largest of the Great Lakes, is 8 times 10 to the 4th square kilometers. The surface area of the smallest Great Lake, Ontario, is 18,160 square kilometers. About how many times as great is the area covered by Lake Superior than Lake Ontario?
Okay, so what do I need to know? Haley? And what lake does that go with? Lake Superior, because it says Lake Superior, which is the largest Great Lake, has 8 times 10 to the 4th square kilometers for area, surface area. What else do we need to know? Dan?
The smallest Great Lake, Ontario, is 18,160 square.
Good. Okay, what else do we need to know? Daniel, what's our question? Okay, so about, and that means what? We're going to estimate, and we need to know how many times great is the area covered by Lake Superior than Lake Ontario. Okay? So, first of all, let's do some estimating. So, which number are we going to estimate? Haley, what do you think? Okay, and we're just going to estimate it to the greatest place value. So what would we round it up to? Sean? If we rounded this number to the greatest place value, it would go up to what? The greatest place value. What's your greatest place value? 20,000, okay? Because this 10,000 is our greatest place value. So the 8 tells the 1 to go up. So we would say this is about 20,000. Okay, somebody put that into scientific notation for me. Jack, can you put that in scientific notation?
That will be 2 times 10 to the 4th.
Yep, because you have to move it 1, 2, 3, 4 places. Okay, so now we have both of our numbers in scientific notation. We're going to use this 8 times 10 to the 4th and 2 times 10 to the 4th. Okay, we want to know which one is, so as great as the area covered by Lake Superior. Which number goes with Lake Superior? Haley? Okay, so that comes first, so that, therefore, it's going to be our numerator. So it's going to go on top. It is also our bigger number of the two. So then what number goes on bottom, Faith? Okay. What do I do with my decimals, Michaela? I divide them. So 8 divided by 2 is?
4.
Okay, and what do I do with my exponents, Adriana?
Subtract.
And so what do you get?
10 to the
4 minus 4 is?
Oh, subtract 0.
0. What is 10 to the 0?
0.
Nope. What is it? Nope.
X.
Nope.
1.
Anything to the 0 power is 1. So this is really 4 times 1, which is what?
4. 4.
I really hope you guys wrote that down with me.
4.
Oh.
4. 7.
Do we have to solve it?
18.
8.1 times 10 to the 10th power. Text messages were sent in the United States. In 2010, the number of email text messages had risen to
1 trillion.
1,810
Billion.
billion. About how many times as great was the number of text messages?
That's not that many.
Okay, so if we're underlining our important facts, in 2005, there was 8.1 times 10 to the 10th.
How do you
Okay.
calculate that?
In 2010, it had risen to 1,810 billion. So that was in 2010. Then we need to know how many times as great was the number of text messages in 2010 to 2005. What else does it have in that question that I should probably highlight? Adriana? About. So what are we gonna do?
Estimate.
Estimate. Which number are we gonna estimate?
The big one.
What do you mean by the big one?
Like whatever that number is.
The one that's not written in scientific notation?
Yes.
Okay. So if we rounded it to the greatest place value, what would it be?
2.
To what?
Two, whatever that number is.
Trillion. Okay. So we're gonna round this to about 2 trillion. So how many zeros do I need?
12.
Okay.
I have to be strong.
So Sean, can you write that in scientific notation for me, and then I'll answer your question.
Maybe 2 times 10 to the 12.
Good. What's your question?
Ooh, how do they calculate that?
What do you mean? How did they take that poll?
Yeah.
I don't know, honestly. But it would make sense that in 2010 it rose because think of how much text messaging has become popular now. I don't want to know. Okay. So I'm going to help you. I'm going to stop here and I'm going to have you finish solving, but I want to reiterate the part where it says, as many times as great as the text messages in 2010 than 2005. What year comes first?
2005.
No, well, okay. What year comes first in the story problem?
10.
And the question? 2010. So which number should be your numerator?
10.
The one that represents 2010. Okay, I want you to finish solving on your own. What number is my numerator? What number is my numerator? Tristan?
2.
Times what? 2 times 10 to the...
12.
Okay, that's my numerator because it goes with 2010. Then what number goes with 2005, Haley?
8.1 times 2.
Okay. What do I do with my decimals? Okay, so take 2 divided by 8.1. What do you get?
0.24391.
So 0.24 something?
Yeah.
Okay, I said round to the nearest tenth. So what would it be if we rounded it to the nearest tenth? So 0.2 because the 4 tells it to stay the same. And then, Sean, what do I do with my exponents?
Oh, that's not good. Let's track.
Subtract them, so it's 0.2 times 10 to the what? To the second. Is that in scientific notation?
No.
No.
Okay, so how do I get it into scientific notation?
Move the decimal.
Michaela? I need to move my decimal back 1. So now I have 2 times 10 to the what?
1.
First, you subtracted because you moved it backwards. Okay, so you took 1 away. If I asked you to solve it out, what would your final answer be?
200.
20.
2 times 10 is?
Oh.
Okay.
Oh.
So your final answer should have been 20.
We have to solve.
No, that's fine.
It was